Okay, this is a nice paper, and it's kind of an extension of an earlier paper that I had already produced as a podcast on large scale heavy rain events over central India. The previous paper was about how the low pressure systems from the Bay of Bengal into the central Indian region meet the secondary circulation vortex, secondary cyclonic vortex from the Arabian Sea to produce these large-scale rain events. This one extends the idea and argues that a lot of them are actually remotely forced, even more remote than Bay of Bengal and the Arabian Sea. There's a lot of dynamics involved here, wave tracing and so on, that I'm going to skip and maybe show only one figure, but the points are very important, so I wanted to include a brief introduction to it. Large-scale extreme rainfall events over central India are produced by monsoon low-pressure systems when assisted by a secondary cyclonic vortex. Both LPS and the SCV are embedded in a monsoon trough and form mainly during the positive phase of the boreal summer interseasonal oscillation. So you have active period and break period over Indian subcontinent, central India, and during the active period you have the trough producing rain, and within that you have the low pressure systems. I've discussed those elsewhere. They are cyclonic systems coming from the northern Bay of Bengal typically into central India. As I said, using ray tracing we show that extratropical Rossby waves propagate to the Indian subcontinent during the summer monsoon season. Stationary Rossby wave rays originating over the North Atlantic Ocean reach India following approximately a great circle path at mid-tropospheric levels. This pathway appears to play an important role in tropical-extratropical interactions during LEREs, large-scale heavy rainfall, large-scale rainfall extremes. They don't define it here, but that's what it was defined as before. The 77% of LEREs are preceded by a North Atlantic blocking high and 90% by a quasi-stationary Central Asian high. The Atlantic blocking high triggers a quasi-stationary Rossby wave response and strengthens the downstream Central Asian high. We'll see a schematic in a minute. In turn, a quasi-stationary Central Asian high facilitates Rossby wave breaking, transporting high potential vorticity streamers and cutoffs equatorward. The Central Asian high is in close proximity to the monsoon trough in the mid and lower troposphere, and that interacts with the monsoon trough over the northwest Indian subcontinent. The equatorial monsoon trough is strengthened due to the supply of dynamic forcing and static instabilities from the extratropics. This additional forcing from the extratropics creates an environment that is conducive to LEREs. Okay. That's the main point, and looking at figures helps just in terms of what the great circle path is. So Rossby wave ray paths at 500 hectopascal for rays starting with initial zonal wave number k equal to 4 during the boreal summer monsoon. Red markers indicate the starting point here. Red markers indicate the starting point, so the forcing location for a given ray. The ray path until day 7 is shown as a dotted blue line, and the rest is a solid black line. So you can see multiple of them, and the black line is somewhere in there. Black or orange markers indicate the position at day 7 or day 14 of integration. The contours indicate the monthly climatological zonal wind, and color shading indicates the same for meridional wind. The monthly climatology shown here is used for the compilation of the Rossby ray path. Only those trajectories are shown for which Rossby rays come from the Indian subcontinent, so 10 to 35 degree north and 70 degree to 100 degree east. The black inside box indicates the study region, which I am not going to get into here. So that's where you are looking for in terms of the large scale rainfall events. And obviously there are lots of assumptions. Rossby wave number 4, and then there are ways in which the ray tracing happens, and in the real world you have a very complicated full three-dimensional flow, and you are going to look for filtered signatures. You're going to filter the variables and look for wave signatures, and that's standard practice nonetheless. So explained variance and so on can be issues, but if you don't understand what is being done exactly, don't worry about it. Just try to remember that there is some generation of Rossby waves happening here in the extratropical North Atlantic, which is able to get around the Central Asian blocking high, the Atlantic blocking high, which produces this standing Rossby wave pattern, and there is a Central Asian high here involved as well to produce the overall conducive environment for rainfall, and that's shown here. So in the upper level and mid level you can see the Atlantic blocking high and the Central Asian high, and you have of course the signatures that we talked about. Schematic explaining the tropical extratropical interactions during large-scale extreme rainfall events, LEREs, over central India. The acronyms ABH, CAH, monsoon troughs, secondary cyclonic vorticity, and low-pressure systems indicate, they are all in here. Low-pressure systems coming from the Bay of Bengal, secondary cyclonic vorticity from the Arabian Sea side. The monsoon trough is over there, sitting in this bigger thing, and you have this forcing coming from the extratropics into the tropical region. Okay, they do nice studies of wave flux, which is indicator of energy coming in and getting, producing a forcing there. Big white arrows represent the path of the wave momentum transport here. This is a bit circular. In the upper level, it's pretty directly shooting because it's above the blocking high. Yellow arrows represent the wave breaking facilitated by Central Asian high that enables high potential vorticity transport equatorward. The monsoon trough is strengthened by extratropical forcing. LEREs are produced in between LPS and SCV, embedded in the equatorial monsoon trough. So this was the original paper by the same lead author, and now she has added this additional part to show that that seems to play an additional forcing role in producing these large-scale extreme rainfall. So I'm going to just jump to the summary and discussion, and I'm going to read small bits of it. We observed tropical extratropical interactions during LEREs over central India. A couplet of blocking high and low forms over the northeast Atlantic a couplet of a blocking high and low forms over the northeast Atlantic about a week before LEREs, so you can see it coming. This couplet is accompanied by a split jet as suggested by earlier studies. The ABH Atlantic blocking high continues to amplify and strengthen the downstream disturbances, forming a Rossby wave train. I'm not showing the figure. The CAH that forms, is that figure 8? Yeah, that's figure 8. The Central Asian high that forms downstream along this train is amplified, and it comes in phase with the monsoon trough, and at mid and low levels it strengthens the equatorial monsoon trough by providing momentum, dynamic forcing, and static instabilities which are needed to extract precipitation. It's Central Asian high and not blocking high. I hope I didn't say blocking, but nonetheless it also facilitates Rossby wave breaking and transports high PV equatorward. A high PV intrusion is observed west to LEREs that can induce vertical motion and static instabilities, leading to extreme convection. Here we note that moisture for LEREs is supplied by tropical circulation associated with the low pressure systems and the secondary cyclonic vorticity, as suggested by Nikum et al., who is also the lead author here. Extratropical forcing supplies additional dynamic and thermodynamic forcing and strengthens the monsoon trough in which synoptic scale LPS and SCV are embedded. The location of Central Asian high is such that it can directly interact with the western branch of the monsoon trough in which the SCV is embedded. So that's basically on this side here. we expect that extratropical interaction would result in the strengthening of the SCV. A modeling study might help in quantifying the contribution from the extratropical forcing and intensifying monsoon trough, SCV, LPS, and thereby during LEREs. Large-scale conditions such as the North Atlantic Oscillation, Atlantic Multidecadal Oscillation, El Nino Southern Oscillation, and the Madden-Julian Oscillation are known to modulate the occurrence of the Atlantic blocking high and the associated teleconnection pattern. Further investigations of these factors might help understand the results reported in this study better, in the sense that Atlantic blocking high, if it is a necessary ingredient, then all these other factors may produce it at the right time to give us these chain of events and lead to large-scale rainfall events on the downstream side. Okay, so it's a nice study, and I obviously skipped, it's a fairly long paper with lots of equations and details about ray tracing and Rossby waves and all the assumptions involved therein. And you can read the paper if you understand the dynamics to that extent, or you can just take this summary and then keep that in mind that they have ENSO impact coming directly, and we are not always sure of that because only 60% of the deficit years are explained by El Nino, only 60% of the excess years are explained by La Nina, and then you have this other mechanism that is more specifically related to intra-seasonal large-scale rainfall events. So there are other ideas that look for how El Nino actually affects the monsoon, and there are papers showing that actually some of the Rossby waves are produced in the northwestern tropical Pacific, and they travel eastward across the Atlantic Ocean back into the Indian monsoon region during El Ninos, but they are passing over this region that's being discussed here in terms of extratropical forcing as well. So I suspect this story is not quite complete, but to the extent that this is seen during so many of the large-scale rainfall events, it obviously needs much more attention in terms of understanding what are the confluences of factors that create the Atlantic blocking high, the Central Asian high, the Rossby waves, and how many of them actually end up being sufficient to produce large-scale rainfall events, right? So necessary condition is one thing, but you have to understand if they are always producing a response, or they are often just waves that come in and don't do much, and so on. Okay, so let's leave this here.